Okay, in this problem we're looking at a situation where a bullet is fired at a target. The bullet travels, hits the target, and then there's sound coming from that hitting the target that returns to the person. And so we know that the time it takes is 1.5 seconds. Now that 1.5 seconds, very important here, you realize that 1.5 seconds is not the time for the bullet to hit the target. At 1.5 seconds, that 1.5 seconds is the time that it takes for the bullet to leave the gun, hit the target, and for the sound of the bullet hitting the target to return. So we have two times here really, and that is the time it takes the bullet to get to the target plus the time it takes the sound to get back, and that's 1.5 seconds. And so we're asked to use this information combined with what we know about the bullet, that it travels at 3,300 feet per second and that the sound travels at 1,100 feet per second, to figure out exactly how far away the target is. So to solve a problem like this where we're talking about distances and times from more than one object, we need to set up a distance, rate, and time chart. And that distance, rate, and time chart will have a row for each distance that you're going to be talking about. In this case we have a bullet and the sound. Now you can go through and fill in the things we do know, which is that the bullet is traveling at 3,300 feet per second. Sound is traveling at 1,100 feet per second. And so we can plug those two numbers in for our rates. Bullet is 3,300, sound is 1,100. Now we don't know how long it takes the bullet to travel there. Neither do we know how long it takes the sound to travel there. But if I let the bullet's time be b, then given the relationship that we've just noticed, time for the bullet plus the time for the sound has to be 1.5. The total time is 1.5. Alright, since the total time is 1.5, then bullet plus the time, which we haven't filled out yet for the sound, has to be equal to 1.5, and that leads us to the fact that the sound's time would be 1.5 minus the bullet's time. And in any distance, rate, and time chart, once you've figured out two of these things, you can then multiply them together to figure out an expression for your distance. So I have 3,300 b and then 1,100 times 1.5 minus b. Okay. Setting the chart up does not solve the problem. It's just a start to solving the problem. What we now need to do is look for some relationship between these distances. Look for some relationship between those two distances. Either they may add up to something, or as is in the case here, because they're going to and from the same target, from the person to the target, from the target back to the person, we know that the distances must be equal. And if the distances must be equal, we can then write out 3,300b has to be equal to 1,100 times 1.5 minus b. And that gives us now a linear equation. Well, once we have the equation, let's go ahead and solve it. $1,100 times 1.5 will be 1,650 minus 1,100 b. So continuing, we need to solve for b, so we want b on one side. So we can add that to both sides. The 1,100b, get 4,400b equals 1,650. So then dividing both sides by 4,400 gives us b is equal to 0.375. Now this does not solve the problem. To solve the problem, we need to refer back to the problem. It's exactly what is it they want to know. Well, in this problem we're asked to find how far away is the target. So notice we don't need to know how long it takes the echo to get back from the target to the person. We don't need to know that, although you could figure that out. We now just need to know how far away is the target. Well, if it took 0.375 seconds for the bullet to get to the target, and the bullet is moving at a rate of 3,300 feet per second, we can multiply those two things to figure out how far it's traveled. So when we do that, we should get 1,237.5 feet. So 1,237.5 feet is how far that bullet had to travel to get to the target. It's about a quarter, just a hair under a quarter of a mile. Just a little bit under a quarter of a mile. So it's quite far distance for that target. So 1,237.5 feet. And hopefully this gives you an idea, or gives you at least a little help now on how to handle distance problems. They're not all the same. They're not all going to follow this format. But the process of setting up your chart, filling out what you know, filling in what you don't know, and then using the relationships in the problem then to write an equation is really the key to using the distance problem, or distance formula, properly in these kinds of problems.